Hello everyone, and welcome to the second in a series of 4 Blue Triangle training videos dealing with the Core Web Vitals. My name's Kieran, I'm a Customer Success Manager for EMEA, and today we're going to be giving you an overview of the Core Web Vitals, what they represent to an end user, and how Blue Triangle can help you to investigate and optimize for them. So, what are the Core Web Vitals? These are initiatives that were started by Google, and each of these technical metrics represents a unique part of the user experience as we traverse across your website. Google sets thresholds for where they consider the site to provide a user with a good and performant experience. Your largest contentful paint metric is measuring the time it takes for the browser to paint the largest piece of content within your browser's viewport, and that's the portion of the website that your user can see. Your first input delay is measuring interactivity or responsiveness. So how long is it taking from when a user interacts with your website for the browser to be able to respond? Finally, cumulative layout shift is a measurement of how visually stable the page is when it loads for your user. You might have experienced this yourself when you go to click a button on a website and the entire web page shifts, causing you to potentially misclick, and obviously this causes frustration for the end user. Not only is improving these metrics one of the keys to a great user experience, but it also ties directly to where you're ranked on Google's SEO, as well as your competitors. So even if we have a great score, it can be important to think about where our Core Web Vitals sit alongside those direct competitors. Today, we're going to have a deeper dive into the first input delay metric. What is first input delay and why should I care? Now, whether you're going on a first date or meeting your in-laws for the first time, we all know that first impressions count. On your websites, a good first impression could actually make the difference between creating a lifelong and loyal user and them never coming back. We see the application of this knowledge in the real world. You may have come across the term supermarket psychology. So greeters at the front of your store, the fresh smell of the bakery pumped over the front doors as you walk in, and the placement of the premium items which the stores want you to buy within direct eye line on the shelves. What your first input delay is measuring is that first impression. Your first input delay measures the time between the first interaction the user makes and how long it takes for your browser to respond. Consider this to be pressing buttons, using checkboxes, clicking a link, or using a custom JavaScript-powered control, and they're all examples of items measured by first input delay. Scrolling and zoom in will not be. This is a separate area that we can measure performance in separately. An ideal response time for FID, or first input delay, is 100 milliseconds. Now, for context, a human blink is around about 300 milliseconds. So that gives you sort of the idea of the speeds that we're working with. On the graph below, we see a representation of a user loading in a web page. We can see resources that are loading in represented by the gray lines. These could be JavaScript files, CSS files, or the base page HTML itself. And alongside the x-axis, the main thread of the browser, we can see tasks that have been executed, and these are represented by the yellow squares or rectangles. They can be long or brief, and typically they're items that are happening such as script executions, JavaScript executions. Now, one thing to keep in mind whilst measuring first input delay is that the same user can click exactly the same button at different times during your page load, and the first input delay will actually depend on the work that's currently being done by the main thread. Some users are going to have no FID values. That is, they load the page up and they don't interact with it and they navigate away from the page. Some users are going to have relatively lower FID scores. For example, if a user clicks at point A within the page load, there's not any activity on the main thread. So we're going to have a pretty instantaneous response from the web browser, and that's going to seem like a very speedy website for your users. However, what happens if a user clicks at point B? They're going to have to wait for the browser to handle the task that it's currently on before it can consider responding to that input. Now, Google is looking at the FID experience at the 75th percentile. So that's 75% of your users on your site experiencing a response to their first action within 100 milliseconds. Now, we know that one of the main causes of a poor FID score is JavaScript execution, and again, that is the tasks that are represented by those yellow bars on the x-axis. Blue Triangle actually allows you to aggregate the experience of all of the users that are visiting your page using the aggregate waterfall features. That is, on the left, function tracing, and on the right, function and object tracing. These trend and average how long each resource on your web page load is taking, and it allows us to actually start to identify those long-running JavaScript tasks that might keep the main thread busy and actually contribute to a poor user experience or first input delay value. We can also help to perform retrospectives on whether the implementation of any of the recommendations that we're about to go through have had any real impact on real user behavior in terms of traffic, in terms of revenue, and in terms of conversions as well. Now, the next question is, how do I go about optimizing our site and improving this FID score metric? That is, without spending significant development time, what kind of performance gains could we reap? Now, I've categorized some industry best practices into buckets of complexity over the next few slides. Obviously, the speed of implementing these will vary depending on your company's structure and what development methodology they work in. But the first slide are quick wins. How can we improve that FID score without spending significant development time? The first thing we can think about is reducing the content that the main thread, that is on the x-axis of our chart earlier, has to pass in order to deliver and act on the resources that it's actually getting on the website. Now we know that every single byte counts. We've managed with one customer to reduce the weight of the page by 10% simply by omitting those unnecessary characters, spaces, and line breaks. And at scale, these can have a real impact in terms of content delivery costs, for example, if you're using a CDN and paying per gigabyte. So getting those files as small as possible and potentially even obfuscating them to help against your competition. Our second recommendation is to use the HTML attribute preload. Now, this allows you to request that the browser prioritizes the critical content on your page, especially items that are not easily discoverable or referenced in your base page HTML. Think of items and images that are referenced inside CSS, JavaScript, or larger images that are considered critical content. Now, another really handy HTML attribute that you have at your disposal that you can apply to your script tags is the async and defer attributes. Think of these as traffic signals that control the start and stop of how your JavaScript is downloading and executing. Now, both of these attributes tell the browser not to actually block your HTML parsing whilst downloading those files, so your main thread can keep busy. Think about how we open the middle highway lane during peak city traffic times. That lane is always available to use, and of course it has its own limits, but it can let a bigger portion of the traffic through if we choose to utilize it. Now for the difference between the async and defer. With scripts labeled async, once this is downloaded, it will execute as soon as the main thread is ready. Now, you can consider putting these items on social media, ads. This is where the order of the execution of the script does not really matter. Your defer tag is also downloaded asynchronously, of course, but it actually waits for the entire page to be downloaded and rendered before the execution of the script happens. These execute in the order that they're on the page, and we generally use deferring for non-critical resources. Finally, let's keep our third parties in check. Now, we all know that many plugins play a key role in the uplift of conversion, traffic, and other metrics, but can you actually quantify the impact that the addition of that tag is having on our website? This leads us to prioritize the loading of critical resources, that is, loading what offers the greatest value to your users first. Does the content in the footer of a website need to load before user-generated content that's in the form of reviews? Or is the browser's resource time better spent loading content that we know drives clicks? One thing we can do at Blue Triangle is monitor this with SLA alerts. So to summarize our quick wins, we're making those files smaller so they can be delivered to the user quicker. We're telling the browser where to find the most important resources that we want to get in front of our users' faces. We're using HTML attributes such as async and defer to control the traffic and allow the browser to do more at the same time. And we're also having a look at how we can keep our third-party plugins in check. We can consider taking a pass on scripts that don't add clear value to our website. So let's have a look at our more moderate plays. The reason we've labeled these moderate is because they will likely require some kind of development resource. So lazy loading. You may be familiar with the term lazy loading when it comes to images. And the basic idea here is that you're loading non-critical resources only where and when necessary. For example, we're on a product page. We want to check whether a store has our product in stock. And what we're doing is we're using a third-party service to do that. Now consider knocking back the loading of this resource until a user shows actually intent to interact with that area, or potentially past our initial page load. This helps keep the main thread more responsive and ready for user input. Number 3, code splitting. This involves splitting your larger libraries, whether that's third-party libraries or your in-house libraries as your code base grows, into bundles or components which can then be loaded in on demand or in parallel. This is a very much lean approach in a similar vein to why we consider lazy loading to be a good idea. Now, number 4 here, which is code optimization. This is a huge one. This is all around dividing your longer tasks into smaller asynchronous ones. And what this allows us to do, or the main thread to do, is actually user interaction to be processed in between those breaks in execution. Now, we all know that well-optimized code will run the best it possibly can on all devices, whereas poorly optimized code gives a relatively weighted poor experience for users with lower-end devices. You don't really control the devices that connect to your website, but you actually do control how performant your code that you're delivering to them is. Now for our more complex recommendations, which potentially might require a infrastructure or a code change. The first thing you can do is utilize web workers. These are a really cool invention that allow scripts to run CPU-intensive workloads in the background in order to prevent scripts from blocking one another on the main thread. The web workers actually communicate with the main thread via an API. So once they've done that work, they tell the main thread that they've done it, and that saves the main thread from having to go and execute that themselves. However, what they don't do is they actually don't manipulate the DOM directly. Obviously, that's a role of the main thread only. But they do have access to certain browser APIs such as network requests and browser storage. So you can really be doing a lot of work in the background and reporting back to the main thread, which keeps the main thread available and ready to respond to user input. We also have server-side rendering. This allows us to move a lot of the logic and page construction to the server side and delivers a ready-made page for the user. This allows, again, the main thread to keep less busy and respond to user input quicker. Recommendation is to revise the polyfills usage. So are users on modern browsers potentially downloading outdated resources they don't need? Polyfills exist in order for users of older browsers to be able to use the site functionality in the same way that a user of a new browser would. But let's see if we can optimize the content that's being delivered to our users. And finally, optimizing your non-critical JavaScript. We might use the async and defer HTML attributes that we learned earlier, but that doesn't mean we shouldn't pay attention to the non-critical JavaScript. Going through the exercise of optimization, that is dividing longer tasks into smaller ones, will all contribute to a positive user experience, not only during FID, but past that first interaction as well. The main thread will be ready and available to respond to user input once the non-critical and critical JavaScript is optimized. Next week, we're going to cover the final Core Web Vital cumulative layout shift, that visual stability. And the week after that, we're going to pull it all together in order to perform some competitive analysis with some large brands. This will help us to see how we fare against our key competitors, but also have a look internally and have a look at how we're aligning to our own technical and digital strategic KPIs as well.